limits at infinity, part 2. Okay, this time x is going to be approaching infinity. And what we're really talking about is end behavior in horizontal asymptotes. But we got a quick example here. They give us a function. This is the graph of that function. And what they're asking for, what's the limit as x goes to infinity and as x goes to negative infinity? So they filled in the chart. And you're looking at the numbers. And it looks like it's getting closer and closer to 3. Same here. When you plug in the numbers, it's getting closer and closer to 3. And what happens is this function has a horizontal asymptote at 3. And as x gets huge, my function's getting closer and closer to 3. So that's your limit at infinity. All right? If you think back to Algebra 2, and you talked about horizontal asymptotes, and you went, oh, this is a second degree. They're both x squared. I look at my leading coefficients. The bells are back on, y'all. School's a real thing these days. Anyway, the horizontal asymptote was 3. All right, so when limits, in this case, the answer to this, as it goes to negative infinity, is 3. Oh, dang it. And positive infinity is 3. Let's go back to blue. Okay, finding the limit of a function at negative infinity or positive infinity finds the end behavior of a function. The line L is a horizontal asymptote of the graph. If it's a horizontal asymptote, if as x goes to infinity of f of x, it equals L, and the limit as x goes to negative infinity of f of x equals L. Here's a theorem of limits at infinity. If R is a positive rational number and C is any real number, this is a false statement. That equal sign shouldn't be there. Okay, so I'm just going to move this over here. The limit as x approaches negative infinity of C over R to the, of x to the R. This one equals 0. As x is getting huge, the bottom of your fraction's getting huge. So you have a constant divided by a huge number, that's going to be 0. Oh, this one is true. Never mind, I was thinking of something else. It equals 0 also, because this is, even if it's a negative number, it's going to get huge, and it's going to approach 0. I was thinking of this, and we're going to get to it later. As x goes to infinity of C over 7 to the x. We'll come back to that. Stay tuned. Okay, so here's some examples. We're really talking about horizontal asymptotes. Think back to Algebra 2. They're both x to the first power. Look at the leading coefficient. It's a 2 over 1, so this is going to equal 2 as it gets huge. All right? This one's bottom heavy. I got an x squared and then x. If it's bottom heavy, it will always go to 0 because the bottom's always going to be bigger than the top. This last one, you have a x to the 4th over an x squared. It's top heavy. In the past, we said it was a slant, but that's not necessarily true. So I'm going to scroll down here and talk to you about non-horizontal asymptotes. Okay? If the top of your fraction, so I'm going to give you an example. F of x equals 3x squared plus 2x over x plus 1. It's top heavy. You said it was a slant. Well, in this case, the difference between the powers, this is x to the first, that's x squared, is only 1, and it's going to be linear. How do I know that? Well, if you divide the denominator into the top, you got to go back and think about long division. What do I multiply x by to get 3x squared? Well, it's 3x, so you get a 3x squared here plus 3x, and you subtract, and you get negative x. This is 0. To get negative x, it's minus 1. This is the equation of my slant asymptote. So if I'm going to graph this, I have an asymptote going through negative 1 with a slope of 3. Okay? Now remember, the question is still going to be the limit as x goes to infinity of f of x. Well, as my x values are going this way, my y values are going this way. So in this case, it would be positive infinity. does not exist is correct, but that's not the answer I'm going to look for. I want this, okay? And the limit as x goes to negative infinity of this function, okay? So here we are. X is going this way. My y's are going this way. They're going to negative infinity. So you have to pay attention, all right? Now, what happens if my function was this? Oh, this is part 2. F of x is equal to 5x to the 4th minus 2x squared over 4x squared plus 1. The difference in my exponents is by 2. You have an x squared. It's a parabola, so this is parabolic. If I divide again, you have 4x squared plus 1 divided into 5x to the 4th minus 2x squared. You multiply this by 5/4 x squared, and you end up with 5x to the 4th minus plus 5/4 x squared, okay? And what happens is I'm going to multiply by some constant here. This is a parabola with a positive leading coefficient. I'm not real picky about it. I don't know where it shifted to or up, but it's a parabolic asymptote, okay? And in that case, when the limit as x is going to infinity of f of x, okay, so here we are. X's are going this way. My y's following that parabola up in the air, so it's positive infinity. When I take the limit as x is going to negative infinity, x is going this way, my y's still going up in the air, so the answer to both of those is positive infinity. It helps define the function for you. All right? Okay, I'm going to stop again and make another video that deals with trig functions and special cases.